Hello everybody, welcome to another episode of System Design. So today what we're going to do is we're going to do Twitter system design. Twitter system design is very standard that most of all of the big tech company have this is Twitter system design. And if you're if you're about to get started with system design, then I think that Twitter is very good things that you can get started, because it's this kind of social medias have covered a lot of technical aspect of system design, so it's pretty easy for us to get up skills in the system design. So yep, let's get started. Right, so the first thing about designing Twitter is that we should probably understand that what kind of scope that we are talking about. Twitter is very big system, of course. So in this video, I'm gonna only talk about several features and several aspects, but of course there are other things that we also need to indicate in the system design as well, but I'm gonna indicate that which one is in the scope for today, and which is not the scope that we are doing for today. So first of all, when we talk about system design, we should gather actually the requirements. And the requirements is actually have functional, non-functional, and the thing that we're not gonna cover, which is our scope in this system design, right? So today I'm gonna only do several services that Twitter is offering. So for example, Twitter, then you can you can follow user, you can have this user profile, and you can have new feed service, or you can favorite a tweet. And very briefly about how such services already work in Twitter. And of course in next video I'm going to dive deep into this such service, but for now it's very brief. So this is all the service that we're going to cover today, and several our scope that we should also indicate, which not cover in this videos. The first one is some analytics service. So we're not going to talk about how Twitter actually collect data for their internal analytics or for their machine learning algorithms or something like that. It's not going to cover. And also we're not going to talk about one of the very interesting service, which is Twitter Firehose. We're not talking about this, and of course not talk about any machine learning system design in this video, or other service other aspect chat system or comments. We're not gonna cover that in this video. And here is non-functional. So what is actually required? Well, in the system design, high availability is very important, scalability, consistencies, and very low latencies, phone tolerant. Right, so the next thing we're going to do is that we're gonna try to kind of analyze some sort of a backup envelope estimation. Right. Well, first of all, before we dive into it, so we should have several metrics that we actually want to talk about this back of envelope estimation. So of course we're interested to know what is daily active user of Twitter. We're interested to know what is how many tweaks per day that our system should have, or we're also interested to know that what kind of traffic, right? So for example, how many requests per month or how many such requests per second. So that is like server traffic that we're interested about. So usually in system design, it depends on the domain or the topic that you are talking about. These might varies, but are some sort of standard template that mostly we're going to talk about, like daily active user, or like our number of tweaks per day, traffic requests per second, right? So something like that. And also interesting to kind of know the space or capacity. So how many like terabytes per month that our system might have, or how many what is throughput that our system gonna have per day. For example, if we're gonna have like 10 billion tweaks per day, then what is their megabyte per second, what is this capacity that we have, right? So let's deep dive into it. So of course, to gather this requirement, you should make it clarify to their interviewer. For suppose that first of all we're doing this, first of all we know the size of one tweet. Well, let's suppose that we're gonna save like tweet ID, user ID, text or content, and some sort of a media content. So what is the total? Right, so tweet ID, suppose that we have 8 bytes. User ID, of course, gonna be vary, but this is all like average number. Suppose that we have 22 or 32 bytes. Text is gonna be 100 bytes approximately. Media is gonna be 10 kilobytes on average, I would say. So in total, it's actually gonna be 10 kilobyte per tweet. Right. So right. So we have like 100 terabyte of new tweet content per month. And if we have like 10 kilobyte per tweet, right? So 10 kilobyte per tweet multiply with 500 million tweets per day, and multiply with 30 days per month, which actually is gonna be approximately we're gonna have like 5.4 petabyte new tweet content for every 3 years. Suppose that what about the traffic? Well, the traffic, we say we have like 100,000 read requests per second, right? Which is actually 200 billion read requests per month. Right. And then we multiply with 400 requests per second, 1 billion requests per month, and it's gonna be 6,000 tweaks per second. right? Right, so of course this is just read request. Apart from that, we're gonna have also search requests, or well, also write requests. So that is several estimation for our system. Well, what about followers? The followers is that, suppose that one user gonna have like 200 followers, right? And of course, one of these followers, they might include some sort of celebrity. So that is also the case that we should think about some sort of edge case. And well, yeah. Another aspect of this kind of estimation that you should think about network storage. We just talking about traffic, right? So we're talking about requests per month, such per month. So apart from that, our network should be able to, store this network of users. So this is social network of users. So you might know this is kind of a graph, connected graph. Well, so this you can think of social media graph. And well, then if we have like 100 million active user, and for each user, for example, we're gonna have like suppose 200 million followers on average, right? So it's actually gonna be like 100 millions multiplied with 200 edge. Right. So edge here is indicate for the connection. So this is graph data. So our network system should also be able to handle this graph their storage. But in this video today, we're not going to talk so much about this. Yeah. All right. And of course, let's say about this system is going to be very heavy read, right? So that is back of envelope estimation. So, yep. Basically, we just going through requirements, features, and then we do some sort of back envelope estimation. So now we know that, okay, our system must be a distributed system, right? But let's not talk about it today. We go from brute force and then we start to scale it on demand. But first, we talk about the simple case first, which is very simple case. Our system is going to handle like very less number of users, let's say 100 users. Then it's going to be very easy, right? So let's think about the most easiest way first. So how we're going to design the system. So first of all, we have like this API design. So, well, simply we're just going to create a tweet, right? And then we just, gonna create users, that kind of thing as well. And then we have to also get the timeline. And to post the tweets, basically in request body, we're gonna have like this user ID, tweet content, timestamp, and the timeline, we're gonna need user ID, location, timestamp. So very easy API that we can think about, right? Right. And what about database? So what sort of a database solution now with this very simple design? Well, we know that our database should have, well, I'm gonna write here. We can have like user table. We just have like this user ID, name, etc. And then we can have like tweet table, which gonna have ID, content, timestamp, what is the number of likes or favorites, and user ID, which is very key of the user table. And these are like one-to-many relationship. And also we have other table as well, like, well, user follow. So this table is actually saving the relationship, the connection between two user. So they have like user ID 1, user ID 2. And from here, it's actually favorite tweet. It's actually gonna save user ID, tweet ID, timestamp. A very simple case, right? Right. So this is very simple version. And well, for simple version, we are gonna have like clients. We're gonna request some sort of request into our web server. The web server is actually have some sort of API, and from this API, they're gonna call to the database. So this is very useful. Well, sometimes you can install some sort of catch here, of course. So yeah, this is a very easy case. But now let's move on, because this system is really need to be scaled. So first of all, why you scale, right? There must be some bottleneck in our system design. So the first bottleneck is that if you think about it, if our very big traffic, big storage is not going to fit into this single design. First of all, with that number of requests, one application server, one web server is not be able to handle that. It's like 1,000 requests per second. We're not gonna be able to handle that big, right? And also the second thing is that it's not fit into one server machine anyway, right? And even database is not going to fit into one single database as well. So this design is actually not scaled yet. So now we have to think about some distributed system, right? All right. So first of all, if you want to increase the number of requests per second, then we need some sort of a load balance. And for this load balance is actually we're gonna routing our traffic to many other server machines. So we are not gonna fit it into only one machine. We're gonna distribute it into many servers, right? And if your number of users is increasing, of course you can always be able to install more server, and this is called scale horizontally. There are another way to scale, which is vertically scaling, which you're gonna install more RAM or more CPU in your server, but that is not really recommended, because of course in the future this kind of scale, that kind of scale is actually not recommended, and because it's like single point of failure. So if one of your servers failure, you only have one server, one big server is failed, then your whole system will fail. There's no way to scale. There's no way for fault tolerance, no way for low latency. It's not really recommended compared to this horizontally scaling, right? So the idea is that we're gonna have many servers, one load balance to distribute the load. And of course, for each server, you actually can be able to install a replica for each server. So, simply, I'm gonna draw like this, right? But the idea, the question is how you can look up each machine to route requests. So we have this hash lookup, right? So one simple case that, for example, you have like n machines. So if we take like modulo of n, then you're going to be able to distribute this request to this kind of machine, so it's evenly distributed, right? But I'm not going to talk so deeply about today. So just give you an idea like how it can distribute equally. Right. Well, so beside this, we should also think about our database. So we are having like very big database. In order to distribute this kind of storage, of course we can have a cache, Redis cache. And this Redis cluster is also distributed cache, right? So we're gonna have like multiple instances in this cluster, Redis cluster. Of course, we're gonna have also this zookeeper with some sort of a resource manager to manage this kind of machine, right? And we also have one very special service that we call it, actually it's not we call, but it's Twitter core. It's actually FANG service. So this FANG service is gonna be distribute load of traffic into these different machines, right? So we're gonna come back and talk about database later, but for now, let's think about back to our architecture that we have like several API for our features, for user, for timeline, are like for if user, favorite a tweet, also such feature. So this is our first simple version, but if we like try to scale it, so we can move into microservice architecture. Which is we're gonna have like different services. For example, this is timeline service, and this is our user service, and this is gonna be search service, for example. Well, I mean different service that you can think of. This is like tweet service, something like that. And for each service you're gonna have like the whole database. So this is like separate of concern. It's not gonna single failure here. So of course this microservice architecture is very fit into our distributed system. Here user might have like Neo4j graph database, for example. Here tweet we can have like different sort of maybe NoSQL might fit here. Just for example, search might use some sort of Lucent database, right? So microservices is that will fit into this distributed system. Well, now we can actually we can go back to, let's go back to database. So before we have one single database that we're talking about, right? So this is SQL database. The idea is that we can use NoSQL database here, but we are more favorite SQL database here because we're going to do a lot of joins and aggregations. So in this case, SQL database more fit into the case, right? So there are going to be some trade-offs for different solutions. So we're just gonna like what kind of solutions you're gonna go for. And we also have like same table database schema that we talked about before. And beside that, we actually want to distribute our database. So, well, first of all, we could have like another database where we actually store object, or blob database where we might store some kind of photo or video maybe. Of course, we can make use of a like AWS S3 here, of course. Yeah, but let's talk about this SQL database. So how we can distribute or fit into, we cannot fit into our storage into one single database. So we're gonna do is that we're gonna shard database, and for each shard, of course, we're gonna have replica for each shard as well, right? And well, what is this sharding strategy? There are like a lot of sharding algorithms, of course, but for example, in this case, simply we could have like user ID if we are using this user database. So user table, we could have like shard by user ID, right? Well, in this case, we can balance load. But the pros is that load is distributed evenly, but the cons is actually, well, you have, it might take you very big overhead, because you might have to query different shard, and then they're jumping to different shard table is of course going to take you some sort of overhead, right? For example, if you want to get top tweaks from your one user followers, so this gonna be some sort of a bottleneck here. And the second approach, well, you can have like timestamp, shard by timestamp, which is like the most recent tweaks, for example, right? Well, in this case, of course, you don't have to jump into different shards. The server is very low latency, but the idea here is that it's not balanced load, right? So, well, there's some trades-off between two approach, and one way that we can think of is like a hybrid approach. So what is hybrid approach here is that, well, we in our database with shard, here we can have like database with shard, right? But at the same time, we can also have some sort of a storage, cache storage, where we're going to save the most recent data or tweaks here. So by doing this both way, we can leverage both benefits, right? And of course, for each shard, we also have replica, right? Here's like a different node of the cache. We also have like replica as well, right? Well, yeah, so that is some sort of a distributed solution for storage for database. Well, what else we can think about? Well, let's talk about, of course we're not going to talk about such service. It's going to be for next video. It's not for today video, but let's actually talk about again the big picture of our whole system design when we're trying to scale already, right? But before that, we're gonna have like our final challenge, that is very big bottleneck that we are not handled yet. It's about timeline service. So the idea is now that timeline is very read heavy, And of course we want to optimize fast read. So well, basically we're gonna install some sort of cache layer before it goes to database. But one idea is that you know, if one user keep like reload his or her time like every 5 seconds, then it's gonna create very high latency, right? So of course real-time loading is in this case creates so high latency. So one approach is that we're actually not gonna we want to try to kind of reduce the time complexity, which we can think of. We might want to pre-compute something first. So we're gonna pre-compute the timeline of every active users. So well, this is user A. What we're gonna do, we're gonna pre-compute the timeline of this user A, and this user have to be active user, right? So of course we pre-compute this timeline, and then we store into cache. So in this way, you know, whenever we just go to the timeline, then we can always fetch it from the cache, which is very efficient. But the idea is that what if this user is follow, let's say, Taylor Swift, right? And if we pre-compute like Taylor Swift, right, which is actually, you know, celebrity trick at load time, which is like, you know, you can, it's like nightmare if you try to do it with all of the active users. And I suppose that all of the active users is always follow some sort of celebrity. So in this way, we have one solution is that we can actually, you know, only pre-compute it from here, but we are not gonna compute any celebrity in this pre-compute phase, but instead we're gonna merge. This is very important. We're gonna merge this pre-compute with this celebrity at load time, and then finally we're gonna catch it, right? So it's only happening load time, right? So this is like a hybrid approach. It's kind of a mix with, you know, in memory, right? In memory cache and on the fly runtime, right? So by this way, of course, we are optimized very low latency read in the timeline. But one way that we can optimize more is that this active user, if they are not being active for, you know, more than 15 days, we're not gonna do this pre-compute. So that is like some other optimization. So now let's move on the last phase that we're gonna, you know, draw this kind of different components of in our design. So we have some sort of client request. It's gonna go to load balance. Of course, if you have like some sort of static request, CDN is always your option. Load balance, this load balance, they're gonna distribute it, of course, different machine here, right? So of course they're gonna be other sort of a server going to be distributed by our low distributed algorithms, and this is like machine ID, right? So we can have like tweak service, timeline service, user service, and of course we can have search service, but not gonna handle it in this video. And like for example, tweet right or read. Timeline is like very read heavily, right? And what else? User. The user is like user service, right? And this we can have like in this sharding database. So this is shard database, and before going to database we always have, you know, this cache layer, which is also distributed cache. But these tweet writers are actually okay. We can talk about it later. And what else here is actually we're gonna have like this like resource manager, you know, some sort of a zookeeper here, right? Well, pretty much like that. And then also in well, this tweet, for example, this is actually using this fan out service, the tweet that we just talking about. This timeline is gonna be using that technique that we are using. Just also talk about that as well. And yeah, apart from that, we of course we're gonna have some sort of streaming service as well, but we're not gonna go so deep into that. So for example, we're gonna use like Kafka or some sort of streaming like Apache Spark stream, and this some sort of things basically for analytics database. So you can also have that as well. So yeah, pretty much that's the end of our analyze system design. Several words is that well, I should probably talk about like, you know, high level architecture first before I deep into each component. But in this way I'm doing sort of a bottom up. I should have been doing top down approach, but I was thinking that maybe I should approach like in different way. But usually in interviews better to go top down approach. And well, of course try to, you know, structure your explanation more. Today I'm just gonna do for like educational purpose, but of course this is not always in real interview that you should do. But of course the knowledge that I give in today's system design, Twitter system design is very quite something that is very valuable for anyone who also like doing the system design interviews. So definitely something that hope that is help for the people out there is trying to review the system design interview. So yep, next time we're going to talk about other domains or topics, and I'm going to try to do it in different approach, not only one way of approach, but of course trying to make some sort of template for your system design and stick to it and do it. And yeah, I mean, I hope that today's videos helps for everyone, and thank you so much.